Okay, good morning everyone. So, let us get started. We were discussing about software cost estimation, and we looked at some very basic concepts, and then we looked at why lines of code, even though it is very easy to measure, why it may not be a good tool to measure the size. And then we said the function points, it overcomes many of the problems that the lines of code has, and then we are just starting to discuss about the function points. Let us continue from there. So, yesterday we were just discussing this point that Albrecht, he proposed the function points, and later the international function point users group that has been promoting function points, and also there were ambiguities about function point, and this has been trying to overcome, producing documentation, support and so on. But let us first see the important concepts, and then we will look at some tools using which you can easily compute the function point. Albrecht, he worked at IBM, and then he understood that lines of code has problems as a size measure. Major problem is that lines of code can be accurately estimated at the end of the project, after the project has completed and the lines of code can be counted, but at the beginning of the project not even a single line of code has been written. Lines of code would only be a guesswork, and when you guess, there is likely to be large error. Can't we measure the size just from the SRS document? So, that was his motivation. And then one thing that was obvious to him is that there is a relation between the number of features or the functions that the system supports, because each function has to be implemented, but then just counting each function, number of functions, is not a good way of measuring size, because these functionalities vary widely in complexity. So, with that intuition, he identified 5 parameters, because just counting the functions is not a good idea. So, he tried to incorporate the complexity of the functions in terms of how many data items the input to the system which change the system state, how many data printouts or displays are produced, how many inquiries, how many files that are internally present and how many files externally present. Let us see those 5 parameters which he identified, which can be counted to give a good measure of the complexity of developing the software, and this can be counted from the SRS document. It overcame the identified problems of the lines of code. For example, lines of code, you would have to think of which language is being used, because the number of lines of code would vary widely, whether it is a C language or assembly language, machine language, Java, etc. So, that would unnecessarily complicate, and the biggest problem possibly was that lines of code had to be guessed, and therefore, if something can be measured from the requirement specification document, and that too quantitatively, which different developers trying to measure for one project will more or less agree and get the same value. So, that was what was required. And not only that, the lines of code required somebody experienced with the development, knows a similar system which was developed, and then based on what was the lines of code he can predict, and the users had no way to estimate the size because they were only aware of the requirements. So, the lines the function point, even the non technical users like those the customers and so on, even they can use the function point and measure size, so that they would be able to find or understand the costing aspects, the time it takes and so on. So, as you will see, the concepts are simple, but then needs little bit of practice, otherwise the measure for the same project may vary. We will see a few examples how to go about developing. So, as I was saying that there are 5 parameters that we can identify from the requirements. So, one is the external inputs. The external inputs are the data that is given by the user or by an external system that change the state of the system. That means, they get stored internally or modified data internally. So, let me just repeat that external input is the data given by the user, which we can identify from the requirements, that what the user inputs and whether the input is being used to modify internal data, and the outputs is how many displays are being produced, and output for each set of related data that is being output will count as 1. User interactions. So, user interaction is where the user invokes a functionality and gives some data which is not used for changing the internal state, but then returning some simple result. For example, we want to search if a specific student is there, or let us say we want to search what is the CGPA of a student. So, to the software we will possibly give the name of the student or maybe the roll number, and that is not used to modify internal data. It is only used to retrieve some result, and those are user interactions, where the user gives input and based on that some results are displayed, but internal data is not changed. The internal data changing is captured by external input and output, and then the external interfaces. So, these are files which are input to the system, and the files may be produced by external systems, external software, or maybe the user might have written those text document or such documents which are input to the software. So, this is external interfaces, and then these are internal files. Internal files can be files internally maintained by the system, temporary files, or maybe data structures that are internally maintained like arrays and so on. So, these we need to count, and then these 5 parameters that Albrecht identified, he assigned weights to them. Each one has different contribution to the size of the software, and based on that he could compute the unadjusted function point count. So, the unadjusted function point, and here the weights that he obtained by regression analysis of several software. He did experimentation, and then he empirically assigned weights based on regression analysis. So, once we get the unadjusted function point, then depending on some characteristics of the software, how reliable, what is the size of data it handles and so on, he refined the initial estimate and get the actual function point count. And we will see that there are tools available, dozens of them available, which help us compute these values. So, this just shows that given the SRS document, which identifies the scope and application boundary, then we can look at the SRS document and compute how many data that is input and how many functions are there, the data input and output and the transactional functions, and then based on that we will obtain the unadjusted function point UFP, unadjusted function point, and then based on some characteristics that he identified, we need to scale the unadjusted function point up or down depending on how easy is the software, what is the reliability requirement, etc. So, based on that we compute the value adjustment factor or VAF and multiply the UFP with the VAF to obtain the final function point or the adjusted function point. So, let us see how we go about, and we will look at few examples and we will look at the tool. So, these are the 5 parameters he considered: external inputs which modify internal data, external outputs that are produced, external inquiries, inquiries are ones which do not change the internal data, just return some result, do something. Then internal logical files, these are data structures like arrays and so on, which are maintained or may be temporary files, and external interface files, these are files which are created by external systems or maybe the user, and these are input to the software. So, that is what it shows here, and the user gives input which changes the data, enquiry which does not change the data, output which produces data, may be a printout or may be a display, and then the external files which are input to the system, and the external files might have been created by the user or maybe by other systems, maybe like an text file or an XML file and so on. So, this is just says that the input data, the output data and the inquiry may not only come from the user, but may be from the external applications, other applications, and the external interface file is also produced by other applications or maybe the user. So, this just written down here the 5 parameters just to have some document notes for you to read later. The interface logical files are the internal data stores which is maintained internally like an array or a list and so on. External interface file is data produced by other systems or the user which are input to the software. External input file update the internal computer, update the internal data. External output display data from the internal data, maybe in some formatted form or a report, and inquiry are those which do not update the computer file. They just access the data internally and produce some result. So, this I have written down for you to refer later what are each of these, and basically whatever we discussed is written down here, serve as a note. So, this is again little bit of elaboration of these 5 parameters, because they are important to understand before we can take up some problems. If we have understanding of these 5 parameters, you can easily identify and compute. So, the external input may be the system displays online forms and the user gives input. There may be several screens, and each related set of inputs would be counted as 1. So, maybe one screen, one form may become one input, or maybe one screen may become 2-3 inputs, depends on. So, there is a bit of discretion here. For example, as long as the data pertains to one student, like his name, roll number, address, telephone number, etc. So, that we will compute as 1, because that pertain to one student. So, there is a bit of ambiguity about what exactly is a related set of data that is being input, which updates the customer information, the internal file. So, there is a customer, this is about a customer software, customer relation software. So, here entering data about the customer, and this updates the internal file. So, this is the external output, where maybe based on some inquiry, or maybe based on input data request that has come, the system produces an output. So, here also we compute each related set of data as 1. Inquiry, it does not modify the internal data, but may input some data like roll number, etc., which are just used for internal processing like searching, retrieving, etc., but then they do not modify the internal data. So, that is the definition of an inquiry. And logical file, this is the data structure maintained internally, and then input data is modifies the internal logical file, and output data is obtained from the internal logical file. External file is something which is either the user has created, or maybe another system reads those file and processes and updates basically the internal file. So, that is considered as an external interface file. And then the weights, classify them, each external input, external output, inquiries, etc., what is the complexity, and based on the complexity weights are assigned. So, as you can see that the internal file which are highly complex, like we have trees and so on, they have the maximum weight, and then as long as they are low complexity, input, inquiry, etc., these have also low weight, whereas the files are the ones which have large weights. Let us take an example. Let us assume that we want to write a spell checker program, and the spell checker has a dictionary internally it maintains, and the user can give a document file and also can give a personal dictionary, like let us say names, etc., words that are used by the user, they should not be flagged as errors. So, the user would input a document file and also a personal dictionary, and then the system would produce a report on the misspelled words, and also the user can query about how many errors have been found. So, this will not modify anything internally, this is just a query about how many errors have been found, and it will produce the number of errors, some message it will produce number of errors. And also the user can give a query about how many words were processed in the document. So, it will output the number of words processed message. So, very simple system, just to explain the concept of function point counting. So, there are two user inputs, because we have to specify what is the name of the file. The user should have created the document file and the personal dictionary, and then the first thing need to do is give the names of these two files, so that the software can open them. So, these two names, the complexity is average or may be low. So, that again is a discretion, and these are the points based on which different persons can get different function point count, slightly different counts, because there is a personal discretion here as how what to consider average and low, etc. So, these two inputs is clear, they are there, but what will be their qualification, whether they are average or low. And then there are three outputs that are produced: the error report, word count, and misspelled error count. So, these are also average you can classify. There are two user requests. So, these are inquiries, these are how many words are processed and how many spelling errors were found. So, these are also reports are average. One internal file which is a dictionary which is maintained, which can be average, or we can say it is a complex depending on what type of file it is. And then two external files that are input to it are the document file that we want to check the errors and the personal dictionary, both are average. So, many of you might say that see just a name may be just a low. Yes, we can do that, debatable. Output reports are also low, but some may say that see the dictionary, internal dictionary may be complex. So, these are the small variations that are possible, and then we compute the unadjusted function point based on the weights we identified in the previous table. So, we get 55, and now the next step would be to refine this. So, this is the unadjusted function point count, and the next step would be to compute the value adjustment factor to either scale this up or down to get the final function point, depending on what are the reliability requirements and so on. So, Albrecht identified 14 characteristics of the software, and each of these we have to judge on a scale of 1 to 5. We will see what does the scale mean, and then the characteristics that he considered are how much data communication involved, is there distributed data processing involved, what about the performance constraints on this, how many configurations exist, what is the transaction rate to be supported, how is the online data entry done, is it a GUI or just a text input, end user efficiency, online update, complex processing, reusability, will the code be produced only for this application, or do we want to write the code which will be reused in other applications as well. The conversion and installation is operational, is how easy it will be to operate, whether the users will be at multi-site, would it be necessary to change it later and facilitate change, and based on this we would compute the adjustment factor, the value adjustment factor. So, 0 to 5 for each of those factors, how much they influence the development complexity. So, that is called as the degree of influence. If it is 0, then it is not present, then these are progressively larger influence on the system and strong influence throughout. So, this will have to increase the count. So, the unadjusted function point, as long as we say that not present or no influence, then the unadjusted function point does not change. But then given the degree of influence, how much do they change? So, this is the formula that he gave. So, total degree of influence. So, as we said that 0 means there is no influence, the unadjusted function point does not change, and if it is very high influence, then it is 5, and just see that there are 14 parameters, and if we make all of them 0, then it will be total degree of influence will be 0 and then it will be just 0.65. So, we will scale down the unadjusted function point UFP that we have computed by 35%. So, it will become 0.65 of what we computed. On the other hand, if we make each of those 14 parameters very high influence, so that is 5. So, 14 into 5 70, 70 into 0.01 will be 0.07, sorry 0.7, 70 into 0.01 will be 0.7. So, this will become 1.35. So, the effect of the value adjustment factor is to either reduce it by 35% or increase it by 35%. So, the final function point count will be something 65% of the computed value UFP to 135% of the input value. So, let us see that we have computed the degree of influence to be 3 of them. We found that they influence 3 degrees of influence for each of the 14. So, all the 14 we just computed as average influence. All the 14 we compute as average influence. So, that is all these 14 parameters, if you can see the data communication requirement, whether there is a distributed processing, transaction rate, reusability, etc., all we made average, and in that case it will become value adjustment factor will become 1.07. So, 0.65 plus 0.042, which is 0.07, 1.07, sorry. So, let us look at another example. So, here we looked at the degrees of influence for each of those complexity factors, like data communication is present and average, distributed data processing not present, performance criteria yes we are concerned for, heavily utilized software no influence, transaction rate medium, etc., etc. Ease of operation is maximum, portability is required, maintainability is required, and then we got 30 as the degree of influence. In that case, the unadjusted function point plus 0.65 into 0.01 plus TDI, which will become 55 plus 0.9. Okay, this is 0.03. So, that is sorry 0.3. So, this becomes 0.95, which is slightly less than 55. So, we get 52.25. So, the result of considering the complexity factors, we scale down the initial function point count from 55 to 52.25. This is another example. We have a payroll application. So, here the transaction to input, amend and delete employee details. So, we are giving employee details which will modify input data, either that will input or that it will amend or it will delete, each of those will change the internal data. So, we write all these as external input and we rate it as medium complexity. Transaction to calculate pay details and time sheet data. So, this is also a external input of high complexity. Print out pay to date details of employee is external output, average complexity, medium complexity. A file of payroll details of each employee. So, this is also medium complexity, and a personal file is maintained by another system accessed for name and address. So, this is a simple. So, then what will be the function point count for this? So, we find that the medium complexity EI is 4, external input is 4, high complexity is 6, medium complexity is 5, medium complexity logical interface file. So, that is 10, and then simple inquiry, that is 5, simple external interface file is 5. So, then totally we compute 30 function point, and based on that we can compute other parameters. So, these are some assignments, please try them out. The result may not exactly match everybody's result, but should be more or less similar. Maybe there can be small discussion about understanding of what is a complexity, high complexity, medium, low complexity. So, I will just display those assignments, and please look at the slides and then try them out yourself about counting the unadjusted function point and then computing the value adjustment factor and then computing with the final function point metric. So, there is another display here about a simple software, about a alumni software, supermarket price scheme, slightly more longer software description, more complex. So, please try this out to compute the function points, unadjusted function point and then the value adjustment factor and the final function point. But then can we have some way to convert function point to lines of code? There have been lot of research, lot of publications that are available on experimental observation regarding each function point, one function point counts, transforms to how many lines of code. This is one result that I am showing. There are small variations of the result produced, but then more or less they converge to this kind of values. So, C language, one function point, to implement one function point we need about 100 lines of code, C++ about half of that 53, HTML if it is a user interface 42, Java 59, J2EE, Perl 60, J2EE 50 and Visual Basic 42. There have been other function points. Actually, the one of the main difficulty with the Albrecht function point is that it is bit involved. Users would have to put substantial effort, and also there can be large variations among different users. Somebody may rate it as complex, somebody average and so on. So, this with that objective, Charles Simons, he developed function point Mark II. Here it based on the ideas of Albrecht, but then his objective was to develop something simpler and more usable method, and which will produce results on which there will be more agreement depending on whoever is measuring it. So, all that rating highly complex etcetera, low complexity, that is not there here, but then it may not be result produced may not be as accurate as the Albrecht function point. If the Albrecht function point is used judiciously with those who understand what is meant by extra complex, moderate and so on, that may produce more accurate result. But this somebody can very fast to compute the function point Mark II. So, here there are only 3 parameters, that is what is the number of data that is input, what is the number of data output and what is the number of entity types that are accessed here. So, may be modified or may be retrieved data from here, each of that is considered as accessed, and data input output is very similar to what was we considered for Albrecht, that a set of related data is computed as 1. So, once we compute that, he gave a very simple formula obtained from regression analysis, number of data input into 0.58, number of entity types into 1.66. See, just see here that compared to input data and output data, the internal processing is taken care by the entity types accessed, and the number of data output is 0.26. So, input data processing is much more complex than producing the output data. So, this is just an example how do we go about computing the function point mark II. So, we looked at the purchase order placement and then find what are the input data there, date, supplier name, product code, quantity required, date required, and then the output data item is the purchase order number, and the entities referred are the internal files, the product, purchase order, supply, purchase order item, and based on that we can compute it NI, NO and NE and quickly get the result. So, this is a larger example where we look at every requirement in the SRS document and then find out the input, output and entity accessed for each of these and then sum total them, and then we use it in that expression to obtain the function point mark II. So, just to summarize before we look at the tool is that it is language independent, clients can use it because we will document what we considered as the external input, external output, inquiries, files and so on. So, it is hard to do very rough guesswork here. There will be more or less agreement on the result. It cannot be like somebody guessed 1000 function point and another person guessed 100 function point, whereas in a lines of code that can happen. But then if we look at it, errors may be introduced by a single person because his discretion of which one to consider complex, simple, moderate, etc. Varies. So, what is really recommended is that if it is really used for a project costing, may be necessary to use multiple raters, multiple people computing the function point, and then the chances of errors will be reduced. So, once we get the function point, so initially we get the raw unadjusted function point and then we get the project complexities we consider and use the value adjustment factor, and that is the problem complexity. But when the project manager considers this, he would have to consider other risk factors. For example, that whether the software is complex for the users who are going to, the programmers, what kind of tools and so on. So, based on that he will have risk factor adjustment. So, this gives him, the project manager is the basic size which he might have to modify and then use it in other estimate techniques that we are going to discuss right now, which will give us estimate of the effort from the basic size estimation, give the estimate for effort, schedule and the cost and so on. But before that, let us look at one tool which you can use to compute function point. There are large number of tools that are available, but we will just look at one tool. So, I have just given a Google search on function point tools, and after giving the function point tool search the Google, found several tools, many are developed by university sites, free tools which you can install, and I have just taken the first search that had appeared first in the search, which is the tiny tools. So, as you can see that it is asking us to enter what is the number of user inputs and then give the weighting factor whether it is simple, average or complex, and then let us say I give some values here, 10 is the number of inputs, number of outputs 7, number of user inputs 15, number of files 2, external interfaces 1 and so on. And then as you can see here, these are all initially set to no influence. There are 6 degrees of influence 0 to 5, and then I just give calculate function point. I assume that there are no degrees of influence. So, that gives me 79.3, but let me just make them high, each of them let us make them high, and then again calculate function point. So, it increases to 164. So, the tool is highly usable if we understand what are the 5 parameters, how to compute them from a problem description, and then the 14 parameters and how to rate them, then it is not a big deal to come up with the function point, does all the calculations taking the weighting factor, etcetera, etcetera. So, now let us look at the other estimation tools. So, size estimation, there are other ways of estimating. One is called as object point. This is even much simpler than a function point. The object point is usable even when we do not know what are all the functions, like we want to get a first hand estimate, and we will see that COCOMO 2 uses it as an initial estimate. So, the object points here we just count the number of screens that would have to be displayed, number of reports that are produced, and how many modules will be there in the code, what are the important parts that has to be implemented, and then this gives us a rough estimate of the size of the software. And another advantage of this is that it considers the effort to develop GUI, whereas in the other ones like function point, we had an indirect way of taking into the GUI development effort, like what is the complexity of the input, output, and so on. There we might give an adjustment factor, there we might classify that to be more complex, saying that the GUI has to be developed, sophisticated GUI. Now, let us look at the COCOMO model, extremely popular, first published by Boehm 1981, and then as we will see today that there are several tools which are available. Many you can free tools you can download on your computer, many you can just use online and so on, and there is a tool also maintained by University of South California, I think USC, where Barry Boehm, his group has also maintained a tool which you can use online. So, he considered regression analysis, because all this algorithmic model, the weights are finally computed based on regression analysis. So, considered 63 past projects of varying sizes, and then based on it he given the size in lines of code. So, COCOMO 1 used only lines of code. He could compute the effort, duration, and then the cost. So, the basic model that he considered is that effort is given as an exponential on size and a multiplier. So, these values of C and K vary depend on what type of software you are using, very simple formula. So, here the size we input is kilo lines of code. For example, if we are developing a software which is expected to be 100,000 lines long, we will write size as 100, and then the K and C values he has published, and also the calculators are available online, which will, depending on how you classify the software, it will give the initial effort estimation. Very simple expression that effort is determined by the size, and there is a multiplier, adjustment factor, and also there is K is called as a scale factor. So, there is a scale factor and there is a value adjustment factor, and to classify the software that is being developed, some software are very complex, some are moderate, and some are very simple. So, he proposed to classify software into 3 types: organic, which are easily developed; semi detached, medium, and embedded, which are complex. and then he said that even if it is a simple software which is being developed by very inexperienced person without using any process and tool etcetera, that may become very complex for them, and we have to consider that as a embedded software. But in normal case, organic mode is one where the developers are very familiar with the software being developed, they have previous experience and the requirements are stable. So, that is called as the organic mode. A semi detached is medium complexity and embedded is the largest complexity. So, here even if the developers have experienced, but if there is great deal of innovation and constraints working with the hardware and so on, then that will become an embedded mode. But a simple software also, if it is developed by developers who have no experience, chaotic development and so on, that may we have to classify that as embedded. So, the effort will increase. So, this is the one that he gave, how to classify into different modes. He said that if the understanding of the software is thorough, then it is likely to be organic, but then there are other factors also. Experience with similar software, if it is extensive, then it is organic. Need for conformance with pre-established requirement. So, very stringent checking with the requirements, then it is if there is a full checking, then it will become an embedded. Need for conformance with external interface specifications. So, it has to work with other software and there is a full need for such thing, then it may become embedded. So, he actually proposed 3 models. One is the basic model which we saw is that a simple expression that effort is given in terms of size, a scale factor and a multiplier. So, that is called as the basic model and has been used in many projects. The basic model has an accuracy factor of 2. So, that may underestimate by 100% or may overestimate by 100%, 60% of the time, and other times it may even be worse. Whereas, in the intermediate model, we take the basic model and refine the results. We use effort adjustment factor based on 15 cost drivers. And here as you will say that see that it also does not consider many things in computing the effort, for example, training requirement, quality etcetera. But still the accuracy is 20% of the actual 68% of the time. So, it is a vast improvement over the basic model and therefore, most project managers use the intermediate model. Basic model is a very raw estimate, whereas here within 20% of the actual 68% of the time, that is another 32% time we might be off by larger variations. And then we have the detailed model where we make a detailed study of the software, different modules and so on. For each one we compute separately and then come up with the full estimation. So, this is much more complex than other models, the basic model and intermediate model, and obviously, it will be, if we used properly, it will give more accurate result than the intermediate model. And these are the values he proposed. So, the basic model is effort is in terms of a scale factor and a multiplier. So, the multiplier, depending on whether it is a easy software, developers are experienced, they understand fully what to do and so on, it is 2.4, whereas if it is embedded, the multiplier is 3.6. So, that increases like 50%, and the scale factor here can vary from 1.05 as the exponent to 1.2. So, this can vary the effort considerably, because it is on the exponent. So, even a small change here may vary it quite a bit. You can just check out if the size is, let us say, 100 kilo lines of code and it is we classify it as organic, what will be the effort? And the same 100 kilo lines of code, if it is embedded, just see the variation there, can easily do a computation. So, this is a summary of that in the table. Organic, the multiplier is 2.4, scale factor is 1.05. Here the multiplier increases by 50%, but the scale factor, this will make a major difference. And once we get the effort, we can compute the development time, and it is called as a nominal development time. It is called as a nominal development time because if we employ the staff in a proper way, then we will get this time. If we employ, let us say, all the staff is recruited upfront. See, the proper way we will see later today in this lecture is that it should follow a Rayleigh distribution. So, there is an initial deployment of few developers at the start of the project, and then as the project progresses we hire more and more people, and then towards the end of the project we reduce the team size. So, that we call as a proper deployment of staff, and that leads to the minimal development time. But if we employ just one person, it will definitely take more time, or let us say we employ too many persons from the beginning, like 100 persons, and we keep that as a constant, that also the time will be more, we will see that. So, this is the minimal time basically, the team size is ideally deployed. So, 2.5 into effort to the power p. So, there is again here a multiplier and then there is a exponent, scale factor. So, the scale factor varies from 0.38 to 0.32, not too much of variation, just see that. And also the effort is the multiplier is the same for all three modes. So, that means that the development time is almost constant depending on what mode you select, whether the software is very easy or it is very difficult, takes almost the same time. What may be the reason? The reason is that the answer lies in the optimal deployment of staff. If it is a complex software, we deploy more people, there are more parallelism in the software, whereas in simple software each one develops and takes time, and that is the reason actually. So, that is what I have written down here. It is roughly the same for all three categories of software. Sorry, 9 is a mistake here, it should be 14, I just written 9 here. So, a 38 kilo lines of code software takes about 14 months, and this 14, if you substitute there, it is regardless of whether it is organic, semi detached or embedded. It may become 13.9 to 14.9 etc., but roughly that much. So, the answer is that there is more scope for parallel activities for complex software. Now, let us get started with what we are discussing, but before that you can notice that there are some questions which have been raised by different participants. I will just read out the question and also give answers to those. So, the first question that was asked RVIT, what are the inputs required to estimate the effort in case of agile model is used? Is the function point or lines of code suitable in this case? Actually, so far we have only discussed the COCOMO 1, and that too not fully, we have discussed halfway, and COCOMO 1 that was developed, as you could see that we discussed that in 1981. So, that is 35 years back, and that time all the development used waterfall model, and also the development was in languages such as C, Fortran, etc. So, the question of agile model did not exist that time, and there is no way we can give input. It has, as you can see, that the adjustment factor have question about whether a process model is being followed or not, and so on, but the concept of agile etc. did not exist. Whereas, we look at the COCOMO 2 shortly, we will see that again it does not really tell that how the effort will vary depending on which process model you use. It says that COCOMO 2, as you will see, that it says initially lines of code is very difficult to estimate. We should use function point during the requirement specification stage, and as we proceed the estimations will become more accurate, and at the after design and code writing stage we can get more accurate estimation, and there you can use lines of code. We will look at that. We are not discussed COCOMO 2, just going to discuss shortly, but the question of function point and line of code in COCOMO 1, that is COCOMO 81, it was only lines of code. That is how the system methodology has been defined, and it did not consider any development models that are being used, excepting that whether there is a process model that is being used or not being used, and that was the adjustment factor. But COCOMO 2 did consider that, but not really which model you use, and as I said that initially start with lines of code, and as the development start with function point that during the requirement specification stage, and as the development proceeds later use lines of code as more accurate estimation of lines of code can become available. Now, let me look at the other questions. Is the estimation process depend on the process model selected? If a software, the effort is the same for waterfall, component based model, etc. Okay, the answer to this question is that in COCOMO 1, that is 81, this question did not arise. They were all using waterfall, and also they were all writing code from scratch. Reuse did not exist. But in COCOMO 2, as you will see shortly, there is this component based development, reuse and so on, which are been considered, and we will see how to use that. And also in none of the models, what is the effect of different process models has not been considered. What are the limitations of agile methodology? So, this is the topic that we discussed in the last class, last lecture, last to last lecture. So, where we said that see the agile model is used when we quickly want a software to be developed. The cost we want to lower, cost and time of development to be lowered, that is the main objective of agile, and accommodate the user changes. But then the quality of the code is a suspect, because the same code is modified again and again, and there is no upfront design. The design is an afterthought. Once the software works, we try to put some design into it. So, if we are looking at developing embedded safety critical software, agile model is not the right model. And also for very large software, the agile model has been successful, that is what has been reported, but then there is no large scale study of how agile model can be used in large projects. But if we look at the agile model, the origins, it was meant for small projects with up to 10 developers. If there are hundreds of developers working on a project, very large project, then agile model was not really developed for that, but then some enhancements to the agile model different teams have tried out and they have reported success. In which phases of the development life cycle is the size estimation done? Okay, in the older times the size estimation was done at the beginning, requirement specification, and of course, the estimation was very gross, because we have to estimate the lines of code and the input itself we cannot estimate, the direct parameter itself is inaccurate and therefore, cost, effort etcetera will be highly inaccurate. But then the project managers kept on using the same estimation models throughout the development cycle. So, first they would estimate during requirements, get a very rough estimate, and as the development progresses use the same expressions, but then they have a better understanding of the software and they can get more accurate results as the development proceeds and change their plan accordingly. But now in COCOMO 2 we have different sets of expressions. Initially take the lines of code, the function point, later on take the lines of code, and also more parameters are considered later on to get more realistic estimates. So, to answer the question in short, that the estimation is done throughout the life cycle, starts with the beginning of the project where we get a very rough estimate and the project manager keeps on estimating and revising the plans, getting more and more accurate estimates. Okay, I think those were all the questions till now. If anybody has questions, please post it, we will look at it and answer. So, let us continue with our discussion. So, we are saying the COCOMO 1 expression about development time is 2.5 into effort to the power 0.3, that is 1/3 roughly, effort to the power 0.3, 33, 32, 38 like that. So, there is not large difference in the development time irrespective of the type of software you are developing. So, let us try to do one example based on the COCOMO 1. So, we are looking at this problem of software package is required by a company to mine existing customer data to select the prospective customers for a new launch. It has been estimated to be 30 kilo lines of effort, because we are using COCOMO 1 in the beginning of the project also we have to consider the lines of code, and assume that competent developers can be hired at 50,000 per month. However, commercial software supporting almost all the required feature cost about ₹1,00,000. Should the company buy or build? So, first we have to consider what is the mode of the software. Is it organic, semi detached or embedded? And as we discussed that the same software can become semi detached or organic or embedded depending on what is the experience of the development team. Have they worked on similar things, or they are totally novice developers, not worked on any team, forget about similar software. But if they are highly experienced, they have developed such software, we can consider this as a organic software. And organic software, if you remember the expression for effort, it is given in terms of the size. So, 30 is the kilo lines of code. So, 30, so 2.4 into 30 to the power 1.05 roughly works out to be 76 or something. You may try out on the calculator, or we will use a COCOMO calculator. So, 2.4 into 30 gives us 70 4 or 73 and then into 72 and then 1.05 30 to the power 1.05, you consider it will become like 76 or something. So, that is the effort person month, and each person needs to be paid, each developer needs to be paid 50,000. So, 50,000 into 76 or 77 whatever comes out, that will be the cost, which is much more than 100,000. So, the question is that should the company buy or build the software? If we only compare the amount to be spent and make our decision based on that, we may not be doing the correct thing. We have to consider several factors in a buy or build decision. For example, are we, if once we develop the software, the intellectual property that is with us, even though we spent initially some amount which is larger than buying of the self, can we sell that software to others? Also, it said that it meets almost all the required features, but then the features that it required features it does not meet. How much would the company who is selling it would charge to make it exactly as we require? What about future upgradations? Like our company might need changes. So, if we ask them to change, how much will it cost? And once we have developers, they can install and maintain it. What about if we just purchased it, nobody will know it, how do they learn it and so on, who will give the training and so on. So, there are many many aspects that we can consider. It is not a simple answer by just looking at the cost of development versus what is purchased. Another factor, important factor may be that if we develop, how much time will it take? Will it take 6 months, 1 year? Can we wait that long? If we purchase off the shelf, is it available instantly, start using? All those decisions have to be taken. So, that is what I have written down here, that how, when it is available, the cost of acquisition and modification, will it be less than when it is developed internally, cost of support and so on. So, there is another example here, that a MIS project costs 38 kilo lines of software, 38 kilo lines of code. So, what is the shortest time, which is the nominal time basically? As I was saying that if we have the staffing properly done, then it will be 14 months. We are going to discuss those issues as we proceed to discuss about the staffing. So, the nominal time or the shortest time by which we can develop without unrealistically bloating up the cost is 14.88 months. So, I should have qualified this question with shortest time to develop without increasing the effort or cost. So, if you have to develop in 109 months, we have to do proper staffing and then we will get 14.8 months. And just see here that written MIS project, but then we need other data like are the developer familiar and so on, so that you can properly classify it into an organic or embedded or semi detached. Now, once the basic COCOMO results are available, that gives a rough indication, and we have to adjust the value by considering several factors of the project called as the cost drivers and multiply those, simple multiplication here for each of those attributes. And then unlike a COCOMO 2, we will see that the adjustment is slightly more complex. Here it is a simple multiplication. So, it multiplies the basic cost attribute multiplier, which may increase or decrease the cost. So, considered the attributes of personnel, like what is the capability, virtual machine experience. So, that means how much they are familiar with the setup, the kind of hardware that is being used and so on. Programmer capability, language experience, have they coded in the, is it a C project and they already know C, or they are not very familiar, they are only Java programmers, application experience, etc. Product attribute like reliability, database size, product complexity, and then computer attributes, execution time constraint. So, are there constraints on how fast the software would complete, storage constraint, how much size data does it need, virtual machine volatility. So, is the software going to work on various types of computers, or is it just targeted to one type of computer? Computer turnaround time. So, this is a factor which says once you submit a job to the computer, how much time does it take to return the result in your organization. Nowadays, it may look laughable that what is this turnaround time and how much time does it take to return a result, but remember that this is developed in 1980, early 80, and that time in a time shared machine, if the same machine is shared by 100 developers, then after they submit a job, it may take a minute or it may take 10 minutes depending on how many developers are working on the same machine. So, this was a crucial factor those days, the turnaround time, but now of course, it is becoming irrelevant, everybody has own computer. Then project attribute, what are the programming practices, that means what are the process model being used, software tools, required development schedule, is the schedule aggressively set or it is set relaxed. So, those are the parameters based on which again we rate it, and based on that rating it may scale up or down, and we will see the tools where you can enter those values and directly it will give you the estimate. So, if we plot the lines of code, that is size of the software in lines of code, and the effort required in person months, we will see that for embedded definitely it requires more effort, and for organic it requires least effort. Looks like a straight line, but it is not, because here the scale is not a linear scale. So, it is 100, 200, okay. So, 1000, 2000, okay. So, okay, it is almost linear, okay, it is almost linear, lines of code and the effort here for the embedded, but here it requires less effort for larger code. So, here if we consider the duration, we will see that even though the effort is almost like linear for each of these, some with the different slopes, the slope for embedded is much higher compared to an organic, but for development time it is a sublinear, and we had already discussed that why that is the case. So, there are some examples here. Once we get the basic COCOMO result, we just multiply the adjustment factor here to get the actual effort in the intermediate model. So, these are the cost drivers, and for each one we need to rate them on a scale of 5, and he gave those values here. We need to multiply the basic result that is obtained, basic model, and then these are the adjustment factors, we multiply that. For example, if the reliability of the software is required to be very high, then we multiply by 1.4, 40% increase in effort, and if we do not bother about reliability, then it is, we can reduce the effort by 25%. and nominal is 1. So, if all the factors we rate as nominal, we do not change the basic result, but then in a typical situation some of these factors may be different from nominal, and we use the appropriate multipliers. So, each multiplier is directly multiplied with the result obtained from the basic model. So, this is another example where the estimated lines of code is 10 kilo lines of code. It is a small project, familiar development, so organic, and these are the adjustment factors of analyst capability. So, there are 3 factors which are other than nominal. These 2 are low and programmer experience is high. So, we look up that table. So, first we use the basic model, it is organic, 2.4 in 10 to the power 1.05 is 26.9, and development time is 2.5 into 26.9, 0.38 is 8.7 months, and then we use those factors, that analyst capability 1.19, we do table of values, we look up that and give these values and multiply each of them directly with 26.9 and we get 40 person month. So, we have scaled up the basic person month estimate by nearly 50%. That is because the programmer capability is low, and the development time also we have scaled up, and the number of people has scaled up. So, there is another example. There is embedded software flight control system, 19 kilo lines of code, and then reliability is very high, and then we compute the effort, duration and the average staffing. Another example here. So, again we compute the effort here and development time here, and then we compute the values. Please try this out. One more example, embedded software, and then we have considered the different effort adjustment factors, reliability, storage, time constraint, tool usage, etc., etc. So, one thing that Boehm said is that once you have obtained the results from COCOMO, the time duration, that is the time with which you can do with the effort that you have estimated. If you want to do it with less time, you need very high staff requirement, and also if you want to reduce the time duration more than 25%, then it will lead to a project failure. So, that was his analysis, that if you have estimated it to last 1 year, then you can at most do in 8 months. Sorry, 9 months. So, that is 75% of 12 months, 9 months. Anything less than that, if you promise, your project will definitely fail. So, why he gave this statement, etc., that we will see as we proceed. And we had seen how to estimate the development time, roughly 2.5 into the effort to the power 0.3. There is another example, the basic COCOMO model estimation. So, one thing that we need to mention here is that the organizations can calibrate the different factors that have been given in the table, adjustment factors, depending on their past projects. And also one thing is that the adjustment factor in the intermediate model, they are directly multiplied, and therefore, they can make a huge difference to the estimation of the effort and time. So, very sensitive to the parameter change this model, and therefore, we can use it very discretely. The parameter adjustment factors need to be estimated very discretely, otherwise it will give large number of error, large inaccuracy. But then the development for which COCOMO 81 was used, the situation has changed significantly. Now, large scale reuse and also we have a component based development and so on, and also the very basic premise that lines of code can be estimated, that also now that the function point is there, should take care of that at least in the beginning of the project. Later, as the lines of code, there is more clarity on that, maybe you can use lines of code, but initially we need to use the function point. So, these are the main objective with which the COCOMO 2 was proposed. So, the changes that were observed were software reuse was increasing, application generation of programs, so libraries and so on, object oriented approaches and agile models etcetera got used, rapid development, and therefore, the COCOMO 2 was proposed. If you look at the COCOMO paper, COCOMO 2 paper written by Boehm, published in Annals of Software in 95, cost models for future software lifecycle processes. So, he mentioned there that the we need to develop COCOMO 2 to have a model for cost and schedule estimation, to incorporate the effect of the different lifecycle practices that are being used, to develop software cost database and tool support capabilities for continuous model improvement. So, we should be able to, the company is using it for different projects that it is doing, should be able to estimate with increasing accuracies. And here in COCOMO 2 is proposed 4 models, unlike COCOMO 1 where there was one model to be used throughout the life cycle. Here we have different models. One is the early design model. This is when the requirements are just available, but nothing has started. So, it is in the early phase of the development. And then we have another one called as post architecture model. So, here we had completed the design and more information about the system is available. We can roughly we can estimate the lines of code here, because we know the design complexity of each module and so on. Fairly accurately we can estimate the lines of code. So, we should use lines of code in the post architecture model, whereas in the early design model where it is hard to guess the code size, we should use the function point. And then there are 2 more here, the reuse model. So, this is when we have significant reuse of components. We have what is the effort required in integrating those, and the application composition model where we have component based development and we are just using those components. So, in a reuse model we are modifying code, we are directly using the code white box and black box, and here we are just having those components available without modifying the internals, just using them. So, that is the application composition model, and reuse model where we are doing a white box reuse. So, as we have mentioned here that in the early design model we use function points, and in the post architecture model we use lines of code, that is the basic size estimate, whereas in the application composition model, which is used even before we have computed the requirements, we have come up with the requirements, do not even know the function point. So, we have only the application points like number of screens etcetera etcetera. So, here we use the application composition model, and the reuse model, here we are trying to customize a software, and how much of the code we are doing white box reuse, how much in the black box reuse etcetera. So, here what is the number of lines of code that is going to be changed and so on. Based on that is the reuse model. And as these are being used during the life cycle, we use different models and we come up with increasingly accurate estimations. When we are just having the conceptual understanding of what is required, not even done the requirement specification, we use the application composition model. And here there are only 3 parameters, as we have seen in the object points. We considered the number of screens, the number of entities touched and so on, number of modules, important modules. So, 3 parameters only, and then as expected the accuracy of estimation is not very high. But after the requirement specification, we use the early design model, COCOMO 2 model, and here we use 13 parameters. We use the function point to do the initial estimation, and then we use the adjustment factors to obtain the size, effort and cost, development time. And then as we proceed and complete the design stage, we have fairly good idea about the code size, and here we use lines of code, and also many more aspects of the software project becomes clear. So, we consider here 23 parameters in the post architecture model, and we get highly accurate estimate. So, in the post architecture model, we consider the source lines of code. Earlier in 81, COCOMO 81, it was DSI, or the delivered source lines of instruction. So, we just counted the number of lines, but here the programming languages have changed, and a single source line can span many physical lines. For example, if we have a if then else statement or a switch statement, then these are considered as one line of code, source line of code, the if then and switch statements. Whereas, if we use DSI, then you just count how many physical lines are there. So, that is one difference. In COCOMO 2, we consider source lines of code in the post architecture phase. So, again the basic model that is considered is very similar, value adjustment factor and size, and there is a scale factor which is the exponent, and then we have some modifiers which are multiplied, and we will see that this takes different shape if we look at the different COCOMO 2 models. Now, let us look at the application composition model. So, here we just consider the number of application points. So, typically used at the very beginning of the development, not even requirements have been specified, and we compute the number of application points, which is basically the number of screens, number of modules that exist, and the number of internal entities or data structures that are being accessed. And then how much of the code we are using? Is it that we are just using a customization, 90% we are just reusing and only 10% we are writing? So, then the number of application point into 0.1. So, that is the application composition model, simple model used at the early development, and one important thing is that it considers the GUI development effort directly by counting the number of screens, reports and so on. So, application point, as we had seen, it is also called as the object points. Here we consider the number of screens, number of reports that are produced and the number of modules. So, here to come up with the rough estimate of the manpower requirement, cost and so on using the application composition model, we consider the maturity of the organization in terms of tool usage and experience and the capability and the productivity. So, if it is very low, then we are going to take large effort. So, these are the values given here. So, if we have very high experience and we have very sophisticated process and tool uses, so we take significantly low time. It actually uses 5 scale drivers. These are the exponent, and the 5 scale drivers are the precedentedness, which says that how much the development team is familiar with the software. Are there any previous example precedent of that same software being used, developed? Development flexibility. Do we have a stringent requirement to meet the budget and the schedule, or can there be a little accommodation there possible? Architecture risk resolution. How effectively are the risks handled? Team cohesion. Is the team well versed, worked earlier together? What is the process maturity? So, the process maturity can be in terms of do they have a quality certification? Do they have a documented process? Is everybody familiar with the process, and so on. So, this is the one which has maximum impact, because this is in the exponent, the scale drivers. The multipliers have relatively less impact on the final result. So, the effort that is obtained is size to the power the scale factor into the multipliers, and then the schedule is again the effort to the power scale factor, and then there are multipliers. And as I was saying is that the exponent here b, we have this expression here, we do not just consider the scale factors directly, but we have this expression here 0.91, the 0.01 into the various scale factor ratings, sigma of scale factor ratings. So, b can range depending on whether it is 0, in that case it will be 0.91. So, the person month will be low here, it can be 0.23, 1.23. So, where the size will be the person month will be much larger. So, if we do not have much experience in the software, it will become larger, not 0.91. 0.91 is if all of them are favorable to the maximum, becomes 0.91. So, it will be a to the power size to 0.91, but if these are all not in our favor, like we do not have experience with previous development of software, flexibility does not exist, we have to meet stringent schedule, budget constraints and so on, risk handling is not proper, team cohesion, the team did not work, they not of the similar background and so on, and then it can become 1.23. So, this again I have written down for your reference, the note. So, this is degree with past examples, they have used degree of flexibility in implementing the project, uncertainty about the requirements and how the risk resolution is carried out, team cohesion, process maturity in terms of the CMMI. So, based on that we rate again the 3, the precedentedness, development flexibility, the risk resolution, the team cohesion and so on. So, this is the depending on whether we have very low precedentedness. So, I have no experience, very low. So, it will become 6.2 in the exponent and 0.91 plus 0.01 into sigma. So, that is the expression, flexibility and so on. So, if we have everything favorable to us, this factor becomes 0. and then we use this in the expression. First compute the B, which is 0.91 and 0.01 into the scale factor, and then we use this in the expression. Many tools are available, we just have to use our judgment here, and then it will give the result automatically. So, the reuse model, this is where we are reusing software. So, there are two things here. One is black box reuse, we do not modify the code, just use it as it is like a library call, whereas here we need to modify the code and integrate. So, this definitely will take more effort than a black box reuse. So, that is what I written down here for your reference and note. So, this is the formula that is used in the reuse model. So, the total lines of code, application software lines of code into the code that is automatically generated, that is reused, black box reused. So, let us say 90% is black box reused. So, the person month will be application software lines of code estimation into 0.1, okay, 0.9 is the black box reuse, divided by the productivity in using doing the black box reuse. It also takes effort and time to do the black box reuse. You have to understand the parameters, make them work and so on. Whereas, a white box reuse, the adaptation adjustment multiplier. So, this will give a much more larger effort in developing. So, here the development estimated lines of code to be developed is the application software lines of code into 1 minus how much is generated. So, if 0.91 is a black box reuse, then it becomes 0.1 application source lines of code into 0.1 divided by application adjustment factor. So, that is the line of code that we have to develop. So, the post architecture level, where we consider lines of code, new lines of code to be developed, do not use function point anymore, because we know the lines of code, and then again use scale factors and so on to obtain the estimate. So, here we have much more factors to consider in the post architecture phase, similar expressions. So, there are some examples here. The company has a CMM level 2 rating and takes on a project in a new domain. The client has not participated during development, has not allowed for risk analysis. So, based on that we can say that risk analysis is very low, development flexibility is high, precedentedness new project, so that is low, no precedent, it is a new project, and team cohesion we take nominal and process maturity as nominal, because I have not mentioned here anything. So, assume that it is okay, and then the scale factor works out to be 1.17, and then consider the multipliers here. So, that was scale factors, and the various multipliers we can consult the table or use a tool which will automatically compute the values based on this table. So, there are few more examples, worked out examples are here. So, this is the scale factor, given scale factor, and then all other multipliers are nominal, and then there is one more example for effort estimation using COCOMO 2, and then we use the duration and then the staffing estimation. So, again we substitute in the formula, we will look at a tool where we just enter the values and gives you these results. So, the original COCOMO, the evaluation of this in real projects, 20% of the actual values 46% of the time, based on 83 case studies that were considered. and then recalibration. So, adjust changes to the different parameters gave 30% of the actual values, 75% of the time. So, this was rest of the time, more than half the time we got widely off the mark. So, here 75% time we got less than 35%. Now, let us look at staffing requirement and the COCOMO 2 tool. I am not spending time here because our time is very less now. Just like we use the function point tool, can just give the search on COCOMO 2 tool or COCOMO 1 tool and you will get dozens of tools. Some can be downloaded, free tools installed, or some can be used online. The one maintained by Barry Boehm's group, you can give input to that online on the scale factors and the multipliers, and then you can look at whether it is which model you are using. Is it the early estimation model or the post architecture model? Based on that, it will give you the results. So, if we have some time later or somebody really wants a demonstration, we can do that today. So, the staffing requirement, let us look at some very basic ideas here. So, here once we identify that the staff, the effort is 100 person month, what is the manpower that we deploy? Is it that we get 10 or 20 people and just start the project, or is it that the number of persons we need to add slowly and build up the team? One thing that had become clear, that Norden in very old result 1958, 60 years back. So, he was analyzing the R&D projects, and then he said in a R&D project, unlike a project which is a construction project or let us say the counters in a shop and so on, is not that, it is a R&D project. So, here he observed that we need to have a Rayleigh curve would model the number of personnel that would be required at any time. If we employ persons which are not Rayleigh distribution, but they are constant, then we will be wasting effort. That was his observation, very old result. So, the Rayleigh curve looks like this. We will see this, the actual equation for this. And later Norden, he was investigating a staffing pattern in software development projects, and he found that the staffing pattern in software development projects were almost similar to that in a R&D project. In a R&D project, initially we explore the concepts, we do some design, experiment and so on. Similar is here in manpower requirement in software development. Initially few people for requirement specification, design, coding and peaks during testing, and then slowly as it gets deployed, the manpower is reduced. So, Putnam found that the Rayleigh curve actually fitted the way for software projects. So, that is what is written down, what I said as for your note, and the time at which the Rayleigh curve reaches the maximum value corresponds to system testing and product release. And also 40% of the area under the Rayleigh curve is to the left. So, the development effort is roughly 40% and the maintenance is roughly 60%. So, that was his observation, and he gave this expression L is the size of the in kilo lines of code, Ck is a constant, K is the effort in person months, and Td is the development time in months. So, that actually gives the Rayleigh curve, and then the constant he gave the value 2, 8, 11 for different working environments. So, the model based on the lines of code we get this. Lines of code is effort, development time to the 4 by 3, and the person month just rewrite this, and k we obtain the person month in terms of lines of code by the constant development time to the 4 by 3 to the power 3, just rewritten this expression, and similarly the time to develop we get the expression. So, Putnam actually used the Rayleigh result of Norton Rayleigh distribution, and then he obtained that if we need to change the schedule little bit. So, T d is the time delivery time. So, if we change little bit, then the effort requirement increases tremendously to the power 4. So, let us say we in the new development time is half the original development time, then it becomes 2 this factor, and 2 to the power 4 is 16. So, if we originally estimated 100 man months, then now we will need 1600 man months just to reduce the development time, but we are developing the same software. So, what is happening to this extra manpower? Earlier 100 man month and now 1600 man months. We just reduce the development time, but are developing the same software. So, what is happening to this extra 1500 effort? They are doing what are they doing? Are they doing something new? No, the same software is being developed. So, where is the effort going? The answer is that once we try to reduce the development time, we have to employ large manpower, and then those manpower we cannot give them work all the time. So, they will be mostly idling. In the nominal effort equation, all developers are busy, and that is the least effort it takes in the nominal development time, that is the original effort. If we want to reduce the development time, we will need a disproportionately high effort, because we will not be having that many parallel activities to keep the developers busy. And also the Boehm's result, it had said that if we reduce it by more than 25%, then it will become impossible to do it. So, the effort requirement increases very rapidly if we reduce the schedule. So, the cost also increases to the power 4. So, even if there is a small compression in delivery time, the result is substantial penalty in the human effort. So, the cost increases rapidly, and every project manager must appreciate this issue, that if we the nominal development time we compute from the COCOMO model, if we the customer demands that we slightly reduce the development time, then the company would incur huge cost in terms of effort, otherwise we will miss the new deadline. So, there is some examples here, please go through. We are running short of time. We tried looking at several topics, starting with different process models, and then we looked at the estimation techniques, size estimation, effort, duration, cost estimation, and then we are looking at the staffing issues. So, unfortunately, the time is getting over. So, these are material for reading, please go through it, and if there are any questions, you please send me an email, we will be happy to answer. And right now, let us see if there are any questions anybody has. So, there are few questions. There is a question that please let us know when we can interact with you. Actually, today is the last session, and we won't have further interaction, but please do send me a mail, I will be happy to answer. Okay, let us see if there are any other question. Which model best best supports reusability. So, I suppose this is a question by Dolly, GECARJ. So, the question is that which model best supports reusability. The question is bit ambiguous. Are you talking of cost estimation or are you talking of a development model? If it is a development model, agile model, as you were saying, that reuse is easy to support, and if it is a cost estimation model, COCOMO 2 reuse model, that is the one. Now, let us see if there are more questions. If anybody has any questions right now, please do write it on the question and I can answer that. Otherwise, you may have to send me an email and I will answer the email. So, we will stop here. Thank you very much.